chain of events, cause and effect. We analyse what went right and what went wrong, as we discover that many outcomes can be predicted, planned for, and even prevented. I'm John Chidgey, and this is Causality. Causality is part of the Engineered Network. To support our shows, including this one, head over to our Patreon page, and for other great shows, visit engineered.network today. Tunnels can be deadly, and today we're going to talk specifically about a tunnel disaster in the tunnel that runs under Mont Blanc in Europe. It's a tunnel that joins Italy and France, and it is the deepest tunnel in Europe. It's 11.6 kilometers, that is 7.2 miles long, and at its deepest point, it's 2.48 kilometers beneath the summit of Aiguille du Midi. It takes approximately 15 minutes to drive through that tunnel. Construction began in 1957, but it wasn't completed until 1965. The tunnel itself was built because the roadway over the top of the mountain was exceedingly long, and this shortcut saves many, many hours, especially for heavy trucks. There's two control rooms, one on the Italian side and one on the French side. And by the end of the 20th century, there had been 45 million trips in nearly 35 years of operation at that point. Its design is a single gallery with 2 lanes in each direction in the same tunnel section. That is to say, there's no separate tunnel for northbound or southbound or eastbound, westbound. So hence it is one tunnel with a center dividing line. There are 18 pressurized emergency escape refuges spaced approximately 600 meters apart, and these were retrofitted in the tunnel in 1990, with some of them upgraded to that point to permit survival of up to 4 hours in isolation. There are 77 emergency phones along the length of the tunnel across each side. These were also upgraded in 1990 to more modern hardware. And there's a 24-hour emergency support team on the French side, manned by full-time employees, with a volunteer emergency team on the Italian side, where they were stationed in case there was an incident. The incident itself. On the morning of Wednesday, the 24th of March, 1999, a morning just like any other, a 40-ton semi-trailer entered the Mont Blanc tunnel. The semi-trailer was carrying a load consisting of about 9 tons of margarine and 12 tons of flour, and it was in a refrigerated trailer unit. The semi-trailer from Belgium entered the French side. The semi-trailer from Belgium entered from the French entrance, bound for Milan in Italy. The driver was a 57-year-old man, Gilbert de Grave, who'd been a truck driver for 25 years. He was a regular user of that tunnel. At 10:47 a.m. local time, the truck entered the tunnel with no issues noticeable or visible. But within 2 minutes, the truck had been in the tunnel, and the first signs of a white smoke were noticed by oncoming traffic coming from just behind the driver's cab. At this point, though, no one signaled the driver. Within about another minute of that point, the smoke became quite visible, and oncoming traffic, they started to flash their lights to try and get the truck driver's attention, to warn him that there was smoke coming from behind the cab. Now, despite the fact that there were 9 sensors equally spaced running the length of the tunnel, they were designed to confirm visibility in the tunnel, but they weren't quite sensitive enough at 3 minutes in to detect the smoke generated at that point. Within another minute or so, at 10:52 a.m. local time, the visibility sensors reached their initial trigger threshold, which was set at 30%, and the alarm went off in the French control room only. The same alarm was normally echoed in the Italian control room. However, that day, it didn't sound in that control room because it had been shut off the previous day due to a false alarm. The false alarm was causing a nuisance to the control room operators, so they turned it off. At this point, neither of the tunnel operators at either entrance had shut down the entrances to the tunnels, and they were still allowing vehicles to enter into the tunnel from either side. At 10:53 a.m., the driver stopped the truck, and now almost exactly halfway in, that 6 kilometers, the halfway point in the tunnel. Upon exiting the truck, the driver tried to grab the external fire extinguisher from its cradle, but in the time that it took for him to grab at it, the smoke escalated extremely quickly into an open flame, and shortly thereafter the cabin exploded in a large fireball. The driver was thrown back from the truck and ran away as fast as he could. which is understandable, really. However, the big problem now was that there were 38 people in vehicles stuck behind the semi-trailer. By 10:55 a.m., the black smoke from the fire went entirely behind the truck and began to envelop the first of the line of cars behind it. One of the drivers that escaped their vehicle made it to refuge number 22, only 300 meters from the truck on fire, and they called the Italian control room to report the fires. And at this point, the two control rooms speak to each other for the first time since the incident began, then decide to shut the tunnel at both entrances to new vehicles. In the first 3 minutes of the fire breaking out, several drivers stuck behind the truck on fire attempted a multi-point turn. Unfortunately, the fire had choked so much of the oxygen at the height of the car's air intakes that the air simply conked out and stopped. The vehicle wasn't wide enough for trucks to turn around, and reversing out wasn't possible, with all the other vehicles stacked in behind the truck on fire, and there was such low visibility, the drivers couldn't see anyway. In an attempt to help to aid the drivers' escape on the Italian side of the fire, the operators pumped additional air into the tunnel in an attempt to clear the smoke for cars trying to escape back towards Italy. At 10:57 a.m., 4 minutes after the explosion, and the emergency response teams dispatched from the French entrance. The smoke was so thick, and there's effectively no visibility, less than half a metre at this point. By 11 a.m., the two French fire trucks got stuck and couldn't go any further into the tunnel due to the smoke and the wrecked vehicles blocking the roadway in front of them. At this point, the fire had then melted through the electrical cabling, and the tunnel was in complete darkness. The fire crew abandoned their two fire trucks and headed for a refuge and stayed there for 5 hours. The Italians then attempted to enter and got within 300 meters of the fire, but the temperature was so hot that the tires were beginning to explode on vehicles nearest in vicinity to the truck on fire. The fire brigade managed to rescue several people in the tunnel, including the driver of the semi-trailer that caught fire. Most of the people at that point, however, were unconscious due to lack of oxygen within only 2 minutes. The next set of firefighters once again attempted to enter, but took shelter in refuge number 24. The firefighters were able to communicate with the outside, however, and were advised another fire crew was also missing, presumably trapped in the tunnel as well. Upon hearing this, they left refuge number 24, and after a brief attempt to find the other trapped firefighters, they returned to number 24, only to find that now there was smoke entering the supposedly smoke-safe and fire-safe room. There were now 15 firefighters trapped across two refuges. However, underneath the tunnel, there is a cable access way called a culvert that also connected through the access ways in the tunnel. Another fire crew entered the tunnel via the culvert and helped the trapped fire crews to escape via the cable culvert under the road about 5 hours later. Back to the truck on fire. At 37 minutes after the fire had started, black smoke began pouring out of the French exit of the tunnel. All efforts to attack the flames are given up, as it's too dangerous and it's inaccessible to firefighting equipment. They had no option but to let the fire burn itself out. There were no other options. It burned for 53 hours. 27 people died trapped in their vehicles. 10 people died trying to escape on foot. And a firefighter also died after being rescued as a result of inhaling toxic fumes from the fire. Death toll was 38 people from the incident. There were 50 people trapped in the tunnel when the fire started, meaning that only 12 actually escaped and survived. The people in the tunnel had died from asphyxiation with only a few minutes of the fire breaking out. They never stood a chance. So, how did the fire start? The truck in question was a Volvo FH12 model, and after an extensive analysis after the event, suggested the most likely cause was a carelessly discarded cigarette butt entering the air intake of the truck, but it was tossed from an oncoming vehicle. As statistically unlikely as that sounds, all of the evidence suggested that that was the most likely cause. The reason was they found particles of pre-burnt air filter fabric inside the engine of the Volvo that could not have been there for any other likely reasons. And although it's not conclusive, ultimately it remains the most likely cause, even if it's not definitively proven. And we have to accept that potentially it is just one of those very unlucky, unfortunate events. It could also have been a fault in the engine, of course, but ultimately it could never be proven. The truck itself was only carrying 550 litres of diesel fuel, so it was only about half full, and that was ruled out as the cause of the fire, though it was certainly responsible for the initial stages of the fire and may have contributed to the explosion. The truth is, though, internal combustion engines are inherently prone to catching on fire since that's how they work, and whilst cars catch on fire, it's not so much of an issue if it's not in a confined space, and a tunnel is a confined space. Now, if you don't believe me that fires in cars is a common thing, then consider that vehicles in the United States between 2010 and 2013 averaged 180,000 fires every year. That's every year. And although not all of those fires led to injuries, fatalities, or property damage, they're scarily common. And people seem to forget just how dangerous internal combustion engine vehicles are because we're so used to them, and we think that the benefits outweigh those risks. The risk of a fire is always a risk when you're driving an internal combustion engine vehicle. The fires are even more of an issue when the fire is in a confined space, like I said before, and the tunnel is one of those. And the risks increase substantially because there are very few exit routes, and the smoke has very few places to go. So the fire itself was incredibly intense. And it wasn't so much the truck as it was the load that it was carrying that was what made this fire so horrific. It was a refrigerated truck, and these trucks usually use insulating walls to keep the cold in and the heat out. Polyurethane was the most common material used, and it was what was used in this case. It burns pretty easily. Margarine has a high energy content, a very high calorific energy content. And when it's melted, contrary to popular belief, it's actually quite combustible. Once you factor in the calorific content of the truck's contents, the truck actually contained the same amount of combustible fuel energy as a 30,000 litre petrol tanker. Fires behave differently in confined spaces, but the fire triangle still applies. You need heat, oxygen, and fuel. Fires can still burn in a low oxygen environment, and if it's a confined space, there may be less oxygen, but it's not totally enclosed, and fresh air can still enter the tunnel. At its peak, the fire generated a peak estimated temperature between 1,000 to 1,200 degrees Celsius, which is 1,800 to 2,200 degrees Fahrenheit, which is very, very hot. Had the driver continued driving until they reached the end of the tunnel, the explosion would have been less likely to have occurred while the truck was still in the tunnel. The movement of the truck at speed can create areas of low pressure where there's less oxygen, but also the heat is drawn away very quickly from the point of ignition, which is, and also think about it as the similar effect as blowing out a candle. Vehicles trapped behind the truck on fire, they consisted of a mixture of cars and other trucks, and combined, they themselves had an equivalent of about 5 fully laden petrol tankers of energy to burn. The smoke given off by the fire travelled exceptionally quickly, at 4.5 meters per second. That's 16 kilometers per hour down the tunnel towards France. As the investigation continued, then they wondered why the smoke had moved so quickly and why only towards France. On the day of the fire, there were some very unusual weather conditions. They occurred maybe 20 days every year, where the relative air pressures on each side of the tunnel made the wind direction through the tunnel travel from Italy to France. Now, there is a ventilation system in the tunnel that operators could operate from either end from their control rooms, and the ventilation duct normally supplied fresh air through the tunnel, and one duct can be used for smoke extraction. At the time of the incident, the Italian operator blew more fresh air in from the Italian side instead of extracting it in an attempt to clear the smoke from that point of the fire back to the Italian side of the tunnel. And there's no doubt that this saved some lives in that section of the tunnel. However, the increased differential air pressure then pushed the smoke's speed up to 6 meters per second, or 22 kilometers an hour. That's 14 miles an hour, which as smoke goes is very fast. Certainly you'd have to be sprinting to outrun that. The CCTV cameras were blocked by so much black smoke at that point in the middle of the fire. The operators actually had no idea how many cars were hidden under the smoke cloud, heading back towards the French side in the tunnel. Now, the smoke itself obviously contained carbon monoxide, which is a common byproduct of burning carbon and oxygen. And our bodies think that it's oxygen because it looks like oxygen, and therefore it displaces the oxygen in our lungs and in our bloodstream. Problem with that, of course, is that without oxygen, we can't survive. And at concentrations between 0.6% and 1.3%, it'll render you unconscious within minutes and dead in less than 15. But that wasn't the only problem with the smoke. Cyanide was also contained in the smoke, and in large enough concentrations that the people stood no chance within a few minutes of being engulfed by that smoke. They would have had rapid onset headaches, followed by confusion, unconsciousness, all within 2 minutes. So what went wrong? Since the upgrade, the emergency phones had been experiencing some technical problems. They only worked intermittently, and a smoke detector at one of the tunnel entrances was out of order. Yeah, but no. I mean, they were certainly minor contributing factors that were brought up in the investigation. I prefer to think of it like this. If we accept that fires are statistically impossible to eliminate, and even with electric cars, even though there should be far, far less, they can still occur. The question is not about if we will have a fire, it's about how we handle the fire when it occurs. Now, just in case you thought this was an isolated incident, there had been a total of 16 fire incidents in the tunnel prior to this one. So no one can say that they hadn't previously occurred. Certainly, they weren't of this level of severity and no one died, but there had been fires previously. Now, the failings in the Mont Blanc tunnel lay in the manner in which it was operated and how emergency situations were planned for. On the planning side of things, during the investigation, it was found that in the 34 years leading up to the fire, only one fire drill had been performed specifically for the tunnel, and it involved the fire brigade, not the volunteer firefighters. The French emergency services also used a different radio frequency for communicating than those in the tunnel, something that would have become apparent had they done more joint training. In fact, it's now a requirement to post a sign on the entrances to building sites, mine sites, and tunnels where channels and frequencies emergency services communicate on to avoid this sort of problem and make sure that everyone can actually coordinate effectively. Regular fire and evacuation drills are now held with all parties involved. Operating was also a problem. At the time of the incident, there were 2 control rooms running in parallel. Now, one of the issues with parallel control rooms is handover of control and coordination of activities. During the incident, in the crucial first minutes when the fire broke out, there was a lack of communication between the 2 control rooms, which led to a misunderstanding of how many cars were trapped where and how the ventilation system should be controlled to get rid of the smoke. In addition, the rules about how ventilation should be used in emergencies such as this weren't clearly understood by both sets of operators. One of the critical smoke alarms had been disabled in the Italian control room due to a nuisance alarming. Now, that was a common occurrence, and that had led to operator desensitization to those sorts of alarms. Their earlier warning may have made a difference. Since the incident, there is now only one control room active during the operation of the tunnel, from which all decisions and controls are made, and operational procedures for fire situations have been completely revised and re-risk assessed. Some other improvements after the incident: refuges are now pressurized so that smoke can't enter them, and each has its own dedicated video feed to the control rooms so that they can tell who and how many people are in those refuges. Staircases now connect directly to the evacuation rooms into the culverts for an escape. Previously, you had to go back out into the tunnel to get to those. There is a permanently manned emergency response team housed in the center midpoint of the tunnel. Emergency response crews are all outfitted with infrared vision systems to find people even with low light or no light. Minimum following distances and maximum speeds are enforced using speed cameras, and strict fines applied to anyone that breaks the rules. On July the 27th, 2005, the French court in Bonneville handed down its sentence. Gerard Roncoli was the head of security at the tunnel, was convicted and sentenced to 6 months in jail with an additional 2-year suspended sentence. Remy Chardin was the president of the French company that operated the tunnel at the time, and he received a 2-year suspended jail term and a fine of approximately $18,000. Gilbert de Grave, the driver of the truck that caught on fire, received a 4-month suspended sentence. 7 other people, including the tunnel's Italian security chief, were handed suspended terms and smaller fines. The 3 companies that constituted the operational firms that operated the tunnel were fined up to $180,000 each. It is also worthy to note that charges brought against Volvo for a potentially faulty vehicle were dropped, as there were no direct faults ever identified in the manufacture or operation and maintenance of the truck that caused the fire. See, we humans, we get complacent. We forget. We're flawed. We forget things. And we get used to things. We get used to the fact that there hadn't been an incident for 365 days. So why would it happen on day 365? Regular drills involving all of the affected personnel for a variety of scenarios, not just one, are vital to make sure that we're ready for when the worst happens. And when we do those drills and that planning, we have to take it very seriously. It's not a joke. It's not a waste of time. It's crucial. The other issue I see is the original flawed design of the two control rooms. In my career, I've implemented multiple control systems that have had multiple points of control. How you coordinate and hand over control from one to the other is critical, so the operator who's there knows who is controlling what. And it's very telling that after the incident, the idea that two control rooms operating at the same time was squashed, and a single control room was deemed to be much safer, and it is, because it's a single point for all of your coordination, a central control room, which is what was needed from the beginning. If communication had been better between the two control rooms in the first minutes the fire broke out, the result may have been very different. So in the end, it comes back to coordination, or in this case, the lack thereof. Their lack of coordination, their lack of organization, from design to operations, cost those people their lives. If you're enjoying Causality and would like to support the show, you can, like one of our backers, Chris Stone. He and many others are patrons of the show via Patreon, and you can find it at patreon.com/John Chidgey, all one word. So if you'd like to contribute something, anything at all, it's very much appreciated. This was Causality. I'm John Chidgey. Thanks for listening.